This is screencast number 2 for Unit 2, Lesson 2, and I am on page 92. So the big purple heading says by the numbers. What is the International System of Units? The International System of Units, or SI, is a system of standardized units used for measurement. The SI system is used by scientists worldwide. This makes it easier for scientists to share information. There are 7 base SI units. Okay? The SI unit of length is the meter. The SI unit of mass is the kilogram. The SI unit of time is the second. The SI unit of electrical current is the ampere. The SI unit of temperature is Kelvin. The SI unit of amount of a substance is mole. And the SI unit of luminous intensity is the candela. Okay. We're not going to use all of those. Some of them you've probably never heard of. But we definitely will talk about meters, kilograms, seconds, and you actually won't start using Kelvin probably until you take chemistry. Kelvin is, the increments are the same size as on the Celsius scale, but the numbers are different. So we'll continue probably to use Celsius. All right, each base unit can also be represented by a symbol. Every measurement has 2 components. So to correctly record a measurement in the SI system, both a number and a unit are needed. And I've talked about that many, many times. If you give me a number and there's no unit on it, I don't understand what it is. You have to put a unit so that I know you're talking about mass or time or whatever it is you're talking about. Okay? All right, so number 9, fill in the missing information in the table below. You can do that simply by looking at the box that they gave you above. Okay. I will also point out that the SI unit of mass is the kilogram, but usually we just use grams. Okay. Kilo is a prefix that means 1,000, so a kilogram has 1,000 grams. Okay. Just like a kilometer has 1,000 meters. Okay. Look at page 93. And it says underline the units derived from the SI base units. Remember, we have 7 SI base units, and they're on page 92. But that's not everything that we need in order to describe certain quantities. The SI base units do not represent every SI measurement that can be made. Other units of measurement combine one or more base units. For example, volume is a measure of the space occupied by an object. The SI unit of volume is the cubic meter. Volume is derived from the base unit for length. Okay, and remember, because volume is length times width times height, that's how you get that cubic meter. Okay, usually we won't use cubic meters, we'll use cubic centimeters. Okay, sometimes derived measurements combine the individual parts of the derived unit. For example, to find the area of a rectangle, measure its sides and then multiply them together. Okay, so when you do find the area of a rectangle, you've multiplied a length times a width. Okay, and they're both measured in meters or centimeters, and that's how you're going to get an area of 12 square meters or 12 square centimeters or what have you. Okay. If you will look on page 93, there are some common derived SI units. Area would be the square meter. Volume, the cubic meter. Because remember, area is length times width, and volume is length times width times height. Now, usually when we do measurements, we're not measuring something that big, so we'll probably do square centimeters or square meters. Weight is also a derived unit because a Newton is actually equivalent to the amount of force that it takes to accelerate a 1 kilogram object at 1 meter per second squared. Okay, so we call it units, but it's really kilograms times meters per second squared. Okay, we'll get into that more when we talk about forces in Unit 4. Density, we've looked at density. That is also a derived unit because you are dividing grams by cubic centimeters, or you're dividing grams by milliliters. Okay. All right, we're going to skip over actually a couple of pages. So join me in just a few minutes on page 96. Okay, I'm on page 96. How do scientists record data using SI units? Okay, your SI units, I'm skipping down to the second paragraph. The SI base units are not always the most appropriate unit for a particular measurement. For example, a meter is not a convenient unit for measuring the length of a bacterium. A bacterium is much too small. The SI system uses prefixes to express SI units that are either larger or smaller than the base unit. Okay. The prefixes represent factors that are based on powers of 10. The reason why the metric system, even though you guys aren't used to it, the metric system is actually a lot easier to use because everything is based on powers of 10. In our customary or English system, we have to remember that there's like 12 inches in a foot, and there's 3 feet in a yard, and there's 1,760 yards in a mile. It's all different. But in the metric system, there are, for instance, 10 millimeters in a centimeter, and there's 10 centimeters in a decimeter, and there's 10 decimeters in a meter, and there's 10 meters in a decameter, and there's 10 decameters in a hectometer, and there's 10 hectometers in a kilometer. Okay, everything's a factor of 10. Okay, and looking at the table that they give you, there are prefixes and there's symbols, and it tells you what factor each one means. So let's look at the middle of the table first. If there is no prefix, then that's just a factor of 1. So that would be where you would start, maybe with meter or liter or gram. Okay. If you go to kilo, so kilometer, kilogram, okay, kiloliter is less common, but you could put that. The prefix kilo means 1,000. So a kilometer is 1,000 meters. A kilogram is 1,000 grams. Okay, that one is fairly common. Kilo is fairly common. Deci, which means 1/10. Okay, a decigram would be 1/10 of a gram. A decimeter would be 1/10 of a meter, etc. A centigram would be 1/100th of a gram. A centimeter is 1/100th of a meter. Okay. Milli is also another very common one, and it means 1/1000th. So a millimeter is 1/1000th of a meter. Okay. A milligram, what medicines and stuff are often measured in, is 1/1000th of a gram. Okay. So everything's a power of 10. It's pretty straightforward. Okay. So how do I go from one unit to another one? How do I go from one that's got a prefix of maybe kilo to a prefix of milli or something like that? Well, if you will go to page R44 in your references, that should help you out a bunch. So we're going to take a quick look at that.